I am Mazhar Iqbal. I am PhD student in ICN Spain and RMIT, and my topic is atomistic modeling of corrosion inhibition, the role of oxide. Atmospheric corrosion is the decaying of the material which takes place by electrochemical reaction of the metal surface with its environment that contain oxygen, water molecules, and electrolyte ion and is associated with various safety and economic losses. For example, copper, which is used in making rolled copper foils, is easily oxidized during the process of storage, due to which its electrical conductivity is decreased. Rate of corrosion can be reduced by various organic and inorganic corrosion inhibitors that get adsorbed on the metal surface and form film. This film acts as a barrier between metal surface and its environment and inhibit oxidation. These studies regarding the absorption mechanism of these inhibitor is very important in order to understand the corrosion inhibition phenomena so that corrosion associated losses can be prevented. Since experimental approaches cannot provide deep understanding of the absorption mechanism, therefore modeling approaches are utilized. People usually use bare metallic surfaces as a model which does not provide a realistic picture of surface inhibitor interactions. Therefore, in order to get the realistic picture of these interactions, complex surface model which contain metallic surfaces covered with the oxide layers are used in order to determine the solvent effect and electrodes potential effect on surface inhibitor interactions. These are the left and right copper electrode at different chemical potential connected with the copper metal covered with the cuprous oxide layer. These are the adsorbed inhibitor molecule and these are the water molecules. This complex surface model will be constructed via DFT calculation, and the solvent effect and potential effect will be studied via QMMM and NEGF approaches. This methodology will help us to understand the adsorption mechanism in details using the complex surface model. With this, I would like to thank all my supervisors and my colleague from Spain and Australia, and thank you very much for your attention.